Okay, so we've turned our machine on, it's in the home position. Now we're gonna get into moving our table and our different axes. In order to move our table, hanging up on the right-hand side of the NC controller is the hand wheel or the pendant. So either one of those terms, hand wheel or pendant, they're interchangeable. If you hear either one of those words, this is what we are talking about. And this is what we actually use to move our table as well as our tool up and down. It's really important to mention that on some of our machines, our NC controller has to be in hand wheel or pendant mode. So we can do that by rotating this toggle switch. And it doesn't matter if you're at 110 or 100, it really doesn't mean anything. Just as long as you are in hand wheel mode, we can now use this to move our axes. So on our vertical milling machine, we have 3 different axes. We have an X, Y, and Z. And that is indicated up on our hand wheel. You'll see that we have an X. I can move to my Y axis, or I can move to my Z axis. I also have a 4. That would be if we put a rotary table on our mills. There's a good chance we won't have that on, just to kind of clear up some of our table space, but we do have the option to put on a 4th axis. Not only do I have what my axis I can move, I also have how much I can move that axis each time I rotate my hand wheel. So I have times 1, times 10, and times 100. But before we get too far into that, I'm actually going to move my table over to the left. So in order to move my table to the left, I need to have my hand wheel in X axis, and I'm going to rotate my hand wheel in a clockwise direction, and you will see that my table begins moving to the left. This is a positive movement. I can also switch to my Y, and I can move my table in and out, or fore and aft. This is the movement of Y. It's really important to realize that all of our axes have polarity. So where I have 3 different axes, I can either move in a negative direction or a positive direction. And then lastly, I have my Z axis, and my Z, I can move down and I can move up. So the best way to determine whether we are moving in a positive or a negative direction is, even though my table is moving, we want to think about it as if it is our tool moving and how our tool is going to be moving along our workpiece. So disregard that it is your table that is moving and think about it from the perspective of the tool. A really nice way, and kind of a cheater way, is if you hold your finger like a gun and then you put your middle finger so it is pointing to the right. When you are looking towards the inside of the machine, these are your positive movements as if you are visualizing it through the tool moving. So for example, the easiest one is our Z. If our Z is moving down, that is a negative movement. Our Z is moving more negative. If our Z is moving up, it is positive. It is a more positive movement. If we move to our X-axis, if we hold our hand like the gun, when our tool moves towards the right, that would be an X positive movement. So I'm in X-axis, and I'm going to rotate my hand wheel to the right, and it's important to know that anytime we rotate this in a clockwise motion, that is moving more positive. So again, our table is moving to the left, but we're going to think of it as if our tool is moving to the right. And last but not least, we have our Y. Our Y, when we look at our fingers, if our tool is moving away from us, that is a Y positive movement. So right now, as I rotate this, I am moving my tool more negative because my tool is coming towards me. It does take a little bit of time to kind of get used to thinking through the eye of the tool. Really you want to think of it like the Cartesian coordinate system or any type of graphing that you may have done in other classes. I want to demonstrate what type of movement we have when our hand wheel or our pendant is in times 100. So right now I am in the x-axis, so any movement I make of my pendant will move my table any given amount. So I am in times 100, I'm going to rotate this one notch. And when I say one notch, when you get to feeling the hand wheel, you're going to feel the little ticks that are involved when you move this. It is very distinct movements. You're going to see that we have moved our table 10 thou. So for every one increment on our hand wheel, we are going to move 10 thou. That is if we are in times 100. What I like to say is times 100, it is like the 401. So the 401 has a speed limit of 100. It is very fast. So when I move out of the way and you see I'm rotating my hand wheel, it is moving my table very, very, very quickly. We can use this to move our tool into position from a distance and cover large distances. When we get close to our workpiece, we do not want to be using times 100 because you get too much movement. It's not an accurate enough movement. So what I'm going to do now is I'm going to move back to my X and I'm going to 0 it, because now I'm going to adjust my hand wheel to be times 10. When I move my pendant one mark or one notch, you will see that I am no longer moving 10 thou, I am now moving 1 thou. So every increment of my pendant will move my table 1/1000th of an inch. So this is what we're going to be using when we bring our tool and our probe in close, because we get a much finer movement. For every 10 increments on our hand wheel in times 10 is equal to 1 increment in times 100. And again, if I'm in times 10 and I want to move my table, you're going to see that I'm still rotating my hand wheel at the same amount, but you can't really see my table moving as quickly. Again, I have to do 10 times the rotations in order to do what I was doing in the times 100. And then finally, we have times 1. If I go X0, enter, enter, now when I move this, 1 increment, you will see I am moving 1/10,000th of an inch, or commonly referred to as a tenth. This is an incredibly tiny movement. The general tolerance or size that we use when we are machining, especially with steel, is thous. So 1 thou. We need to move my hand wheel 10 times in order to move my table 1 thou. So this is an incredibly small movement. I strongly suggest that we don't use times 1, because you will be here all day and all night moving your table into place. And just to show you how slow the table moves, I'm just going to step out of the way. And again, I am rotating this handle at the same speed, and I doubt you can see that table moving. In fact, in this entire time, I have only moved this half an inch, the table half an inch. So it is such a fine movement. I don't recommend using times 1. I recommend using times 10 and times 100. One thing that I find causes a lot of crunches and bumps and bangs within the machine is when we get a tool that is really close to a surface. Right now you're going to see inside my machine that my tool is incredibly close to my workpiece. It would be really bad if I brought my tool down. I don't have a lot of movement for this tool will hit the top surface of my workpiece. So no matter what, if you're coming close to your X, to your Y, or your Z to the surface of your workpiece, I find the safest thing you can do, when in doubt, is rotate your handle to the Z axis, be in the times 10 motion, and rotate your hand wheel in a clockwise direction. So you want to be in times 10 because obviously that's a nice slow movement, but you can still see the tool moving away so you don't get impatient. You want to be in Z because really your tool being close is kind of, I mean really your tool is the most dangerous part of the machine. And then you want to go clockwise because we want to bring our tool up and away from that surface. So no matter what, maybe we're really close to our x-axis and we don't know whether we should move to the left or to the right. If we go to our Z times 10 and rotate this in a clockwise motion, our tool will come up and away from whatever obstacle we're worried about hitting. As soon as we get a couple inches from the surface of our workpiece, then you can flip to times 100 and move your tool up and away into a safe position. One thing I find that happens with a lot of students is they go, I can't remember which way to move this, and they just start cranking the hand wheel like this, and it may not look like much of anything, but that could be enough movement to hit your workpiece, and then we have broken an end note, which obviously we're going to try to avoid, okay? So let's, before we make any movements, really think about what we want to do and what motion we want our tool to make, and when in doubt, Z-axis times 10 clockwise.